I'm glad you're here for the help video for quiz 3.09. So here is your need to know info. The first thing is the tangent theorem. A line that is tangent to a circle is perpendicular to the radius of the circle at the point of tangency. Okay, so remember, a line that's tangent only touches the circle at one spot. That's what makes it a tangent line. And if you connect the center of the circle to that point of tangency, that radius is always going to be perpendicular. So that's the tangent theorem. You also need to remember the triangle sum theorem, which just says that if you add up all the interior angles of a triangle, they always equal 180. And then the last thing, you need to know how to find segment lengths of chords, secants, and tangents. I think on this quiz, we actually only deal with 2 chords, but I went ahead and put all the formulas there because you need to know all of them. All right, so let's jump in. It says AD is tangent to the circle B at point C. All right, so let's just see what we're looking at here. This segment, AD, or this line, is tangent to the circle at this point right there. So we automatically know that that's a 90-degree angle because that's what our tangent theorem tells us. Is that if you connect the center of the circle to that point of tangency, if you make that radius, it's a 90-degree angle. And then it says, what is the measure of angle BCA? Oh, well that's what angle we already marked. We already know angle BCA is 90 degrees, so there's our answer. Okay, the next one. AD is tangent to circle M at point D. So again, we have a tangent line. That means it's a line that touches the circle at just one place, which is point D. So we automatically know that point of tangency is 90 degrees. They have to be perpendicular. And this one says, what is the measure of DMQ? So let me go ahead and color code that one. From D to M to Q. Oh, I missed something. Sorry, it says DMQ is 50 degrees. So I know that angle is 50 degrees. And then it says, what is the measure of DQM? So I read that totally wrong. We are looking for this red angle right here. This is what we're trying to figure out. Okay, it may be hard for some of you to see, and it may be super obvious for others, but we have created a triangle. So let me just draw that triangle over here. And in that triangle, we already know that this is 90 degrees and this one's 50 degrees. And if we know two angles of the triangle, we can find the missing one because they always have to add up to 180. So we could do 90 plus 50 and then subtract that from 180 to figure out that missing angle. So that missing angle has to be 40 degrees. All right, what is the value of N? So we're kind of switching gears here. We don't have a tangent anymore. We have 2 chords. Remember, a chord is just from one side of the circle to the other. If we look down here, our formula, and these are not on the formula sheet, they do have to be memorized, is part times part equals part times part. And now when I say part times part, I mean they have to come from the same chord. So I'm going to color code my chords. So I have a yellow chord and a green chord. So I'm going to start off by doing part times part of the green chord. So 3 times N. Those are my 2 pieces. I have this piece 3, and I have that piece N. And I'm going to set that equal to the part times part on the yellow chord. And so I'm going to set it equal to 4 times 6. That's one part of the yellow chord, and that's the other part. And then it's a nice, simple equation for us to solve. 6 times 4 is 24. 3 times N is 3N. Divide each side by 3. And this segment would be 8 units long. So there we go. This one says, what is the value of N? Again, we're given 2 chords, so we're going to use that same formula, that part times part formula. So I have this yellow chord. If I do part times part from the yellow chord, it would be 18 times n plus 1. And then I also have this green chord, and if I do part times part from that one, it would be 9 times n plus 7. Just make sure that when you do part times part, they come from the same chord. You don't ever want to do like 9 times 18. Those are on 2 different chords, so it does help to color code it. All right, and then from here we have an equation to solve. We're going to go ahead and distribute 18. 18 times n is 18n, and 18 times 1 is 18. We're going to do the same thing over here. We're going to distribute it. 9 times n is 9n, and 9 times 7 is 63. I had to really think about that for a second. Let me double check that. I'm having a moment. Yeah, okay, it is 63. All right, and then we have n's on both sides. I like to move them to the left, so I'm going to get rid of 9n. Right now it's positive 9n, so I'm going to subtract 9 n's from each side. That will cancel out. 18n minus 9n is 9n. Plop the 18 straight down and bring that 63 straight down. All right, my ultimate goal is to get n by itself, so now I need to get rid of positive 18. So I'm going to do the opposite. I'm going to subtract 18 from each side, so that cancels. So 63 minus 18 is 45. And then I have to divide by 9. And so n equals 5. And just let's always go back and check the question. The question does say, what is the value of n? So we are done. If it had asked for like a specific segment, like if it had asked for this segment, you would want to go back and plug that in. But for now, that's it. All right, last one. Which statement about line BC is correct? All right, so let me highlight BC so I know what I'm looking at. Well, I totally just missed the line. Let me try that again. That's a little closer. Okay, so BC is a tangent line. If you notice, it only touches that circle at exactly one spot. Goodness, y'all. I'm riding the struggle bus. There we go. So it only touches the circle right here at point B. And remember, we know anytime we have a tangent to a circle, that is going to be perpendicular. Okay, so let's see what our options are. Line BC is tangent because angle ABC is acute. Doesn't matter what that angle is, that doesn't help us at all. BC is a tangent line because the sum of the angles in the triangle add up to 180. So let's do it. Let's add up those angles and see if they equal 180. So we got our triangle here. Y'all. So, you know I put that 90 degrees there? We actually don't know that yet. I didn't even read the question carefully. It does not say that BC is tangent to the circle. Goodness gracious. Y'all be nice. I make mistakes all the time. It says what is correct about BC. So we're not exactly sure if that one's tangent or not. That's what we're trying to verify. And in order to verify it, it would have to make a 90-degree angle. Goodness gracious. Sorry, this explanation is all over the place. But I know I've got my triangle down here. I know this one's 48 degrees and this one's 47 degrees. So I'm going to find this missing angle. And remember, all of them have to add up to 180. So I'm going to add those up and subtract from 180. So when I add them, I get 95 degrees, and if I subtract from 180, we should be left with 85 degrees. So this angle here is not a 90-degree angle. It is actually an 85-degree angle, which means that BC is not tangent to the circle. Sorry I started that problem off totally wrong, but I hope that you're sticking with me through the correct explanation. It is not tangent because this angle here is not 90 degrees. And when I say here, I'm actually looking at this angle right there. That would have to be a 90-degree angle in order for this line to be tangent, and it is not because of the triangle sum theorem. So there you go. Good luck on your quiz, and I hope to see you on the next help video.